Welcome to clickmyproject.com. Let's discuss about the product. Our product is region of interest extraction based on frequency domain analysis and salient region detection for remote sensing image. Traditional approaches for detecting visually salient regions or targets in remote sensing images are inaccurate and prohibitively computationally complex. In this letter, a fast, efficient region of interest extraction method based on frequency domain analysis and salient region detection, that is hereafter called as FDA-SRD, is proposed. First, the HSI transformation is used to pre-process. That means we are taking RGB image as input in the databases. So taken RGB images are processing as HSI transformation. For the remote sensing image from RGB space to HSI space is converted. Second, frequency domain analysis strategy based on quaternion Fourier transform was employed to rapidly generate the saliency map. Finally, the salient regions are described by an adaptive threshold segmentation algorithm based on Gaussian pyramids. Compared with the existing methods, the new algorithm is computationally more efficient and provides more visual accurate direction results. A region of interest is a selected subset of samples within a dataset identified for a particular purpose. The concept of ROI is commonly used in many application areas. For example, in medical imaging, the boundaries of a tumor may be defined on an image or in a volume for the purpose of measuring its size. The endocardial border may be defined on an image, perhaps during different phases of the cardiac cycles, for example, end systole and end diastole. In geographical information systems, an ROI can be taken literally as a polygonal selection from 2D map. A region that draws attention is defined as a focus of attention, which is considered an ROI or a target. Several computational models have been developed to simulate the human visual systems. The remainder of this paper organizes as follows with the illustration and the development. Remote sensing images comprise a high amount of data. The biological models can be simulate the HSV, but they often lead to prohibition, computational complexity, and not consider the characteristic in frequency domain. Further, human visual attention does not necessarily reflect actual concern in a remote sensing image. Additional researchers in different disciplines calculate ROI quickly, but they only consider the features of the image itself. It is easy to cause false or missing detection. To overcome the weakness of the existing visual attention models so that they are more suitable for processing remote sensing images, we focus on two aspects: accuracy and low computation. The salient regions should be detected and well described. Thus, we propose FDA-SRD, that is frequency domain analysis and salient region detection model. This model is proposed to improve computational efficiency and accuracy in ROI detection of remote sensing images. After the HSI transformation, a novel frequency domain strategy based on the quaternion Fourier transform is being used to generate a saliency map. Let's see the flow of our process. So this is the black diagram which represents what are the flow which included in our proposed system. So initially we have taken the input images, that is so all the images we have taken are RGB, that is red, green, blue combination. So as a pre-processing, after filtering, we are transforming RGB image into HSI, that means hue, saturation, intensity, and after the HSI combination, we are combining HSI and we are obtaining HSI image. The HSI image is forced into saliency map, and from that we are applying threshold segmentation. So we are giving particular segmented part during this, and that results are binarized, and binarized results are masked with the original region, and finally we will get an ROI result. Let's see the demonstration of our product. As we already discussed, our product is based on MATLAB programming language. Hence, we are using MATLAB 2013 for our implementation. So you can see these are our directory. Our directory includes what are the files included in our project backup. So this is source or our details which you select in the file. Recording details will be displayed here. This is called workspace. The temporary values will be in a mat file, and you can see by double clicking it. This is command history. This is the main command window. So you can see there are two similar names. There are similar names with different formats, .m and .figure. So .m files are normally programming file, and .figure files are graphic user interface. While I am running main1.m, that will call main1.figure, because that means I am running program file. The program file will call its corresponding window. So our window is designed based on graphic user interface. So we can run either by double clicking and processing run. Otherwise, I can press F9 to process. So this is our main panel here. These are the push buttons. Initially, I am selecting the image which to be processed. For that, I am selecting insert image. So that will go for a database folder. Here there is a region. I am selecting the image. So given image is RGB, I am converting that into hue, saturation and intensity. So you can see the HSA image here. This is the HSA transformation, and we are identifying saliency map from that, and threshold segmentation. Threshold based binary segmentation applying here, and after that we are doing binarization. So binarized result is here. You can see the difference between original and our processing image. So we are masking the segmented result with the original image. You can see the region of interest we have obtained from original. So these are the final results we are obtaining, and then results. So these are our overall demonstration of our product. Thank you.